Today we're going to talk about solving systems of equations using elimination. We've already solved systems by graphing and by substitution, and this is yet a third way to accomplish the same task. Elimination, however, is the method most preferred by many students. We're going to be able to add or subtract and eliminate one variable in order to solve for the other. The main idea of elimination is to have a set of terms that match so that we can add the two equations together to get rid of one variable. And let me show you what I mean. Here I have a set of equations. Both have x variables and y variables and constants. And notice that our y terms actually do match. They're both 3y's. They do have opposite signs. One's a positive 3y and one's a negative 3y, and that's exactly what we want in elimination. Before we can start to add these equations together, we need to make sure that everything's lined up so that all variables and constants are together. My x terms are lined up, my y terms, the constants, even the equal signs are lined up, and that's an important part too. Now I can simply add the two equations together. I can add the x terms. I get 7x. When I add the matching terms, and this is why they need to have opposite signs, 3y added to negative 3y cancel, and we have no y's left. We line up the equal sign and bring it straight down, and then 16 minus 2 gives us 14. Look at the equation I have left. 7x equals 14 means that x is equal to 2, and we've already solved for our first variable. The second step to elimination actually shares or has in common what we did in substitution. We're going to take x equals 2 and substitute it into one of our original equations to solve for our missing variable. I can choose one or the other of my original equations. It doesn't matter which one you choose. Either one is going to give you the same value for y. So in this case, I'm just going to pick the first equation. Substituting 2 in where I used to have an x, I can multiply. I can subtract both sides by 4. And I can divide both sides by 3, and I get y equals 4. And now we have an x-coordinate and a y-coordinate for our solution, the point 2, 4. Now, what to do if there isn't a matching variable, because unfortunately our world is not perfect and we don't always have a matching set of variables. In that case, we're going to force there to be a matching set of variables by using multiplication. And just on a side note, you can multiply one equation, or you can multiply both equations by different numbers in order to get a match. So let's take this system of equations. I neither have matching x terms or matching y terms. But I can actually have a matching set of y terms if I take the time to multiply my first equation by 2. If you multiply part of an equation by 2, you need to make sure to multiply the entire equation by 2, and I get 6x minus 4y equals negative 24. A really common mistake made by a lot of students out there is forgetting to multiply the constant by 2 as well. Don't forget to multiply the entire equation. My second equation can stay exactly as is, and now I have my matching set of terms with opposite signs that allows me to use elimination. Adding the x terms, my y terms will cancel, And that's going to equal negative 22 when I add my constants together. Solving 11x equals negative 22, I get x equals negative 2, and I already have my first variable. Substituting into one of our original equations, again, it doesn't matter which one you pick, so this time I chose to use the second equation. Replacing x with negative 2, I can multiply, I can add both sides by 10, and divide both sides by 4, and I get y equals 3. And now I have my solution, the point negative 2, 3. Remember to be careful to always put the x-coordinate first and the y-coordinate second. All right, one more. How about this system? There's a few things wrong with this system. The first, I'm sure you've already noticed, nothing's lined up. That's what we need to take care of very first. So let's take that first equation and let's line it up like we had our other equations. Let's bring that negative 15y to the other side. So if I add 15y to both sides, I get 4x plus 15y equals 7. Then let's look at the second equation. To get x and y to the same side, I can add 12y to both sides and add 21 to both sides. So moving things around, I get 6x plus 12y equals positive 21. Now I can line them up and notice that nothing matches. This is an instance where I'm going to have to multiply both equations in order to get a matching set of terms. I'm going to choose to have our x terms match this time. Since I need them to have different signs, I need one of them to be negative and one of them to be positive. So I'm going to multiply the first equation by negative 3, the second equation by positive 2, and that's going to give me matching x terms, one positive, one negative. Don't forget to multiply that value through the entire equation, especially the constants. Now when I add everything together, my x terms will cancel. I'm left with negative 21y's equals positive 21. Dividing both sides by negative 21 gives me y equals negative 1. Now I go back and choose one of my equations to substitute negative 1 in for y. If I choose my first equation this time and replace y with negative 1, I can multiply, combine like terms on the right, and divide by 4. Dividing by 4 gives me 22 over 4, which reduces to the fraction 11 halves. I could also make that a decimal. That equals 5.5 if I choose to. And then I can put them into my solution, 11 halves, negative 1. Okay, let's finalize what we did today. First of all, make sure that everything's lined up. Your x values, y values, or x terms, y terms, constants, and even equal signs. Second step is to multiply if needed in order to make a pair of matching variables. Make sure that one is positive and one is negative. Then we add the columns to solve the equation and solve the leftover equation or the remaining equation to solve for one of the variables. Then we substitute the answer of our first equation back into one of your original equations to solve for our second variable. And that wraps up our systems by elimination. I hope the rest of your day goes great, and I'll see you next time.